Pull this into our nice U shape here. So thank you very much. Okay. Where we're at. Hold your stone here. While you do this, bring that round table over there. Okay. Perfect. Thank you very much for helping me out. We have a little more than I was. Oh. Yeah. Okay, good. We have more than I thought, because Heidi had said it was going to be like 10 to 15. That's great. It's because you all love math. That's why you're here. No. All right. And as you come in, a couple of things. We're passing around the sign-in sheet that is part of the grant. Go ahead and sign in and out so that we have that all taken care of. If you are missing your IEN number, because they have that on the form, it's really okay. Okay? And then one other thing before I get started, I did set up a bit.ly for this, so it's got the slides with all kinds of resources and links. So if you want to go ahead and type that in, feel free. If you don't have a device right now, just record it for later. And I'm going to give you just a moment to kind of get that all in place before I start. And let me know if it's shared with you okay. Oh, you don't have to capitalize, sorry. So it's Math Practices 3-8, and I did not put any spaces in. If it comes up for you, will you give me a thumbs up so I know we're doing okay? All right. Yeah. Okay, then we're going to go ahead and get started. When the sign-in sheet gets to you, just make sure you fill it out completely so you're official with the state. First of all, I want to say hello to intermediate. I have not met you yet. My name is Kristen Clegg, and I have had a wonderful time working with your middle school teachers. I'm a full-time math consultant, so what that means is that I travel all throughout the Chicagoland area. Back in the day, I used to travel nationally, but then I started having kids, and it just was too hard. So, and I live in Streamwood. My children are a part of the U46 school district. So, so now my role is I float school district to school district, certainly leading sessions like this, PD sessions. But I do a lot of classroom work too. So I get into the classrooms and I either do coaching and modeling, or my favorite form of classroom work is I facilitate a lot of lesson studies where I bring teams of teachers together and we devise a lesson to help us learn from our learners. And we go into the classroom and we really study the way students are responding to the math tasks we give them. So I share that with you because that has a huge impact on everything that I'm going to share with you today, because one of the most challenging parts of teaching in a real good standards-based way is to tackle the math practices. And I think the math practices, when I'm in the classroom, they're very intriguing to watch. Like, what gets students to really operate deeply with math and to become mathematicians. So that's what we're gonna delve into today, okay? Just so I can get a read on the room, where are my third grade teachers? Just so that I have a sense. Okay, fourth grade. Ooh, you're flying solo today. Okay, fifth grade. Ooh, excellent. And then I know our middle school. Excellent. Okay, so today, as we get into the math practices, We're going to be doing a couple different things with the math practices. First thing we're going to do is, I don't know if you even know this, but the math practices, all 8 of them have this nice beefy paragraph that goes with them that describes what the authors really were. Oh, hello. Hello. Oh, we do need more. So we'll set up that round table in the back then. So the math practices, each one of them actually has a nice beefy paragraph that explains what the authors intended from that math practice for the students. So we're going to do a real brief unpacking type of activity with them, okay? But after we unpack the math practices and we get a sense of what they are all about, we are going to look for them in action. So we're going to actually watch a classroom video. We're going to listen. We're going to listen and look for the evidence of those math practices from the students. I think it's always nice. I mean, our ideal would be to run a lesson study where we're all in the classroom together. So second best to that is to visit through video. Okay, so we're going to try to connect these practices to what it really would look and sound like in the classroom. And then a big part of what I want to offer you today is specific strategies and resources that you can take right into your classroom. Okay, so that will be how I kind of finish out our session. So you've got some things to study this summer, because I'm sure you have nothing else to do. And hopefully these would be strategies and resources that are easily implemented for you. Okay. So first question, before we do our little unpacking activity, when you signed up for this session and you saw that it was titled Math Practices, what were your thoughts? I'm just curious what you associate with the math practices. So I say math practices, you say what? How to teach. All right. Excellent.
I was going to say problem solving.
Problem solving? Strategies. Nothing else come to mind initially. That's totally fine. That's why we're going to unpack. All right. So it happens to be all 8 of these math practices. When you open up the Common Core document, they are actually filled with paragraphs that describe each of them. I think we oftentimes are so focused on our content standards that we haven't had the luxury of like putting a pause on and really delving into what these math practices call for. So that's what we're going to do. I'd like you to go ahead and take a copy of the wording. I hope I have enough. We'll see here. And what I'm going to do is I'm going to walk around and break out the 8 mathematical practices. I'm going to put you into probably a group of 3. And what I want you to do is I want you to take that math practice, take a moment to read the paragraph, mark it up, and I want to know from you what words or phrases are jumping out at you. And then I'm going to give you a chance to kind of talk with your little group and see if you had similar things that jumped out at you in the language, and see if you can find a way to sort of summarize that math practice. Okay, let me do a quick count. If I think I'm going to give this a try. You guys are going to be math practice number 1. Congratulations, that's the most challenging one. That's the meatiest one. If we do it this way, let's do math practice number 2 here. We're going to do math practice number 3. Yeah. Can we do math practice number 4 here? And if you guys are going to do practice 5. Okay. We're going to do practice 6 here. And then we'll put you guys in charge of 7. Okay. And I'll finish out 8. So feel free to go ahead and jump in to reading it and marking it. And then when you're ready, you can talk with your work. Did we have enough?
You didn't capitalize the M. Yes.
That's okay, no, leave 3.
Oh, yeah, oh, yeah.
Yeah. Yes.
Yeah. Okay, but no worries, I'm gonna, we'll continue with video and all of that, so. And in fact, when we talk about each one of them, if you think of things we had discussed back when we did it, to add to the conversation, we'd love that. Okay, so. So let me just kind of help you with one thing, that when I see in mathematics contextualize, I think of a word problem and like pulling the math out. That to me is the decontextualize. And the contextualize is any form where you take the math and numbers and symbols and you put them back into it. Whether that's used to answer the question or maybe you give your students, number sentences and make up a story. It's that process of going from words to math. Exactly. But I want you to think of context as like a story context. Okay. Yeah. Oh, needless to say, but to your got a great one, but you know, analyze. When you and your group members feel like you have kind of a way to summarize, just give me a little thumbs up so I know you're ready. That was fast. Practice one. Nice job. Did you guys mark the same thing? Yeah, that's what I figured. Yeah.
I was like,
thank you so much.
Wait, just one paper, 2 sides.
Yeah.
yeah. Oh, excellent. They took it
All right. Okay, so I'm gonna have everybody bring their eyes back up front. Okay. We're gonna do, here's what we're gonna do. We're gonna run through each math practice, kind of hear the group's take on that practice. But then I'm gonna pop up onto the computer some posters that Katie has displayed up here. These are posters that come from Jordan School District, but the nice thing is they made them different for each grade band. So I provided, like when you're on my slide at this stage, I'll have links to all the different grade bands, okay? I think the one that I'm choosing to present is the 2-3. I think I went pretty primary with it. I don't remember what I'm about to say. But some of the earlier grade posters are a little bit simpler visually. You can see that the middle school posters are pretty heavy wording, okay? But first thing we need to know is what you thought about the math practice, okay? So I gave this group math practice number 1, make sense of problems and persevere in solving them. And to me, this is like a doozy of a standard of a practice. So let's hear what you thought.
We just talked about how it says a lot of the meta technicians, so really thinking about their thinking, and just having the kids understand the problem, and if they get it wrong, they persevering, through the problems, but they do get it wrong, and they keep going. A lot of kids will stop.
Excellent. I love the use of metacognition. I think that's a big part of it. And the persevering, somewhere in that paragraph, they talk about, like, if they figure out that their pathway, the strategy they've chosen isn't working, that they have the ability to select another strategy. That's really rare that we see that kind of perseverance taking place in the classroom, and that is our ultimate goal. I do really want you to look at math practice number 1, though, as like, hey, all school year we're working toward this. This is not a practice that's going to happen in a day. And I almost think of math practice number 1 like we're training athletes. We want them to be able to endure the problem-solving process, to not just give up initially. And that takes, like, some exercising, some skill practice, and we slowly start to build up to this ability to persevere so much so that, hey, this isn't working for me. Let's pick another way. I mean, that's really difficult stuff. Jordan School District, when they did this poster, this is what it looks like on the grades 2-3. I kind of like some of the earlier grade posters because of the formatting. I like this idea of before the students go through the problem-solving process, well, actually, this is part of the problem-solving process, but before they tackle the math, because I watch lesson studies all the time, I'm sure you see this, where the kids will look at the word problem, they'll grab the numbers, they haven't even read the word problem, they just do something to the numbers. Well, we're wanting them to go through a whole process where they plan out what they're going to do, they process during, they have the endurance to figure out, hey, this isn't working, let me pick another way, and they have a way of kind of concluding the process, checking their work, thinking about, does this make sense? And in the primary group this morning, we talked about this fact that there's almost a before the before. Heather, do you want to share a little bit on that?
We just talked about the reading comprehension piece. Before they can even figure out which strategies they're going to use, they have to be able to understand even what the question is asking. And I know we tackled this a lot.
Yeah. So I do have a strategy that I'm going to share with you today that is a close read strategy for math, because sometimes it's just reading. It has nothing to do with the math yet, but they don't even have access, like Heather said this morning, they can't access the math until the reading has taken place. So it's almost like we need a before the before. All right, that's that doozy of a practice. Practice number 2, what did you guys say for that one?
So basically it's just talking about taking a word problem and pulling out the math, and not just pulling out the math, but understanding what each of those numbers mean. So
Understanding the math problem on a deeper level.
yeah, like what is it, before we just go and multiplying, what does 1/4 mean in this problem before we do that? And then just if they're proficient students, they're able to kind of understand, be able to pull out, understand the numbers, and then put it back into somewhat of a sentence or an explanation, explaining what they did.
Excellent. And Jordan School District did their poster this way. I personally tend to think of it like these two panels are flip-flop though. Because more often in math classroom, we will tend to give them sort of the word problem, ask them to extract the math and work with it. I think your paragraph even said as if it has a life of its own, didn't it? Is it that poetic on that one? I think it does.
Oh,
Or maybe it's on another one.
no, it's yours, yeah.
So, okay, anyhow, it's very poetic. Oh, there you go. And then take the math and put it back into the context, which it can be exactly what you said, like make sure that the number you're getting, that the students can answer what it had to do with the story in the first place. The other thing is, you could be doing tasks with your students that challenge them to develop the story from the math. And maybe some of you are already doing those types of activities where we give them the math, but the students have to make up the story. But the key thing with this one is that back and forth between the two. Excellent. Math practice number 3.
We tried to paraphrase this one, and it's that when students offer their answers, we're hoping that it's based on prior work they've done or on the concrete objects in front of them, and that they can explain why it's right. And they can listen to other students' answers, evaluate and give feedback to them, and they learn to explain why their own work or other students' work makes sense.
Ooh, they evaluate it and give feedback. That's huge. Excellent. Oh, nice summary there. Their poster kind of splits it into those two phases, that idea that we want students that can explain their thinking. And you said something about like show why it works or something.
Right, either because of prior work they've done, like the problem, this other problem we did, or if they're using manipulatives.
Excellent. And I really like that point because when I'm in classrooms, sometimes the students are not equipped with the language they need to explain their thinking. But if we give them like a document camera with some manipulatives, they can show their thinking. So I would really encourage you to think when you're doing this math practice as like we're asking the students to convince us. I'm always finding that we're putting in the language you need to justify your thinking. And that justification can come in a verbal form, it can come in a pictorial form, it can come in a manipulative form, but we want access to their thinking. And then to be able to, I like that they have mirror here, because that's much more difficult. I don't know if you find this hard to develop in your classroom, but sometimes students are just like very narrow in, I have done it, I've completed it, I did what you asked me to do, and it's really hard. If they're not equipped with a deep mathematical understanding, they can't even take in what somebody else is explaining. So this is a challenging part of this. For me, I've tried to infuse, with the teachers that I work with in the classroom, we've tried to infuse a lot of tasks that ask students to look at others' work. Whether it be, just an example of how someone solved it or that partner work where they evaluate each other. Yeah, excellent. Okay, math practice number 4. What did you have on that, ladies?
Okay. We just said that a lot of it is applying what they learned in real life. So taking the knowledge they've learned and then being able to apply it in any situation.
Love it. And the way they did this is they just put a word problem in the center and said, here's the centerpiece of this practice. Math is actually used to solve things in our world, and there are lots of ways to solve it mathematically. So when you see their poster and you see the branches out, it's just to consider all the ways of dealing with that story or with that real world context. By the way, are you seeing some overlap in some of these practices? That's very similar to yours, right? Yeah. Okay. Math practice number 5.
This just talked about the students being familiar with the tools that are available or resources available to solve
various types of math problems, and then them making conscious or logical decisions on which tools they should use for various problems, based on, we talked about the insight that can be gained from these resources and also the limitations of these tools.
For me, the part that I never did in my own teaching was challenge them to select the tool. I feel like I set up lots of manipulative lessons, technology lessons, but I always kind of said, today we're exploring this. And that one is really asking for them to pick.
And we also found that like they use the word estimation so the kids can see if they've used this tool and they've already estimated on what the right answer or what the right solution should be close to, did they use it correctly?
Good. For third grade, I'll just share with you that I know some primary grades that set up little math toolkits. They actually make, use like a shower caddy, and they have all their little tools in it, and kids walk around with it. For more of the intermediate into middle school, I've seen a variety of setups with materials. I've seen perimeters set up with materials where the students can choose to go out and grab the tools that they need, or like quads set up with materials in the center. Any other formats I'm missing for how to make these tools available to students?
I think you could just have like one set of bins too, they go get it, take it back, you know. so
Oh,
then
yes,
you
grab
wouldn't
an
be
entire
setting-
bin.
You didn't have space to set things up every day.
Okay, and the next practice.
We had number 6, we just talked about how the student should be able to explain their work and define what it is they're doing, using the symbols, labels accurately, things of that nature to make sure that they really truly are understanding what it is that they are working on.
Yeah, and I think it's just going beyond just the number. So you'll see on the poster that they've listed a variety of things. I think that this is something that we can be sort of establishing as the culture in the classroom, that this one says, you don't just get the right answer. That's not what the precision is about. It's also the way in which you communicate it. So when you're communicating to others, you need to reference the story. You have to have labels. You do need some precision with the way you're using symbols.
I have to say, with just from my observations with using CFP3 this year, I've seen the kids get better at labeling. Like I don't have to be like, well, what does 25 mean? Like I actually see them labeling more than I ever have seen.
And what do you think is causing that why do you think CMP3 is causing that to happen? What is it about the program?
Well, I just think because everything is, you know, we have a story, we have every, you know, it starts that way. It's not just the numbers, we're starting with that real world context.
Yeah.
So they have it in their heads right away that we're talking about something else.
Yeah.
Not just numbers.
And intermediate, just so you know, when middle school is working with their program, everything, like Alicia said, is housed within a story. Like they catapult into the math by first dealing with a story. So everything has meaning, which encourages this sort of labeling form. All right, and math practice number 7, which is kind of dry. Sorry, guys. What'd you say on that?
It was just looking at patterns and structures and how to take larger ideas and break them down, you know, taking those really complex ideas, breaking them down into something that's familiar or looking for those patterns.
And 7 and 8 are very similar. So 7's talking about looking for the structures, but 8 is like repeated reasoning. They're both sort of patterns and the way our number system is built too. I think we find ourselves having that happen within many of our lessons naturally. So I kind of, in my thinking, I pair those two together. I see them as sort of algebraic in nature and looking for patterns. So now here's my question. When you think of all 8 mathematical practices, which one do you think is the most difficult for you to develop in your classroom? Why don't you just give me a number? Which has sort of stood out like, oh man, this is just hard to accomplish? So show me a number, just so that I can kind of see. Oh, that's funny. Julie's gonna have like an ongoing, 1, 2,
That's
or
just
3.
like 1,
1,
3.
2, 3.
Yeah.
Alright.
Oh, yeah.
Yeah. I just wanted to gauge it.
Yeah, bottom up.
Yeah.
Stopped.
It's interesting, when I'm in classrooms, those are the ones that I'm most focused on. Yeah.
I think 3 is the toughest, but if they can't do 1, they can't do anything else.
Yeah.
Oh, really good point. Which is why I think 1 is almost the umbrella of everything, isn't it? Don't you feel like too, that sometimes you have to like be able to persevere in your students persevering?
And not.
Not give them the answer, right? So one of the hardest things, when I facilitate lesson studies, we anticipate that they are gonna look at us and go, I don't know what to do, you know? Because that's one of the hardest moments to not just swoop in and save the day, which removes the whole learning process from the child. They need that struggle, but they need some supports within that struggle. And that's why I think this one is just really hard to work with. I did include, I just remembered, on one of these slides, I have some resources that have good questions for the math practices, that when I write lesson study plans, we put those questions into our plan. Like, we anticipate there's gonna be struggle, so what are we gonna ask the child? Or how are we going to reconstruct the task? Are we gonna change the wording? Are we gonna give them additional materials? But oftentimes it's questioning lines. So I think questions are really, really powerful for that moment of struggle.
And get them to ask the right question. You know, rather than just saying, I don't get it.
So actually,
You know, ask me ask me a question, don't tell me you don't understand it, but then sometimes I look at it and they don't know what their question is.
you got it, you got it. I think that takes some training. That questioning resource that I have attached for you could become something you give to the students, actually. So that when they are not sure what to ask, they could almost be looking at this list and finding a question to pose. Okay? So here's what we're gonna try to do. We have all these 8 mathematical practices. We're gonna see if we can find them within a classroom video. But to help you with that, I'm gonna give you a tool that is called a look for tool. And it takes all of the 8 mathematical practices and says, if that practice is happening, here's what you should see and hear from the children. And it says also, this is what you should see and hear from the teacher. So it has little check boxes of like what the evidence should be. Okay? And we're gonna try to use this tool. Take a look at it for a moment, make sure you have it digested. If the tool looks overwhelming to you and you're like, oh my gosh, Kristen, you want me to look for all of these check boxes, then just narrow it. You can narrow it to just the first page, or even if you just want to look only at the practice I gave you today, that's completely fine. Okay? I will give you a little heads up though, that they did not put the practices in order, they paired them. So they put practice 1 with 6 because they felt like they went together by overarching habits of mind. I think that's really the main place where they mixed up the order, okay? But we're just gonna look for criteria. I probably wouldn't even go into the teacher column today. I think I'd just be focused on the students, all right? Okay, so here we go, movie viewing time. We're gonna watch a lesson from the teaching channel. Has anybody used the teaching channel? You have to use the teaching channel. Here's how you have to use it. This is how I use it. I go on, I watch what everybody else is doing. I find a lesson where I thought the teacher did a great job and the kids are responding great, and I steal their ideas. And they have it set up, it's free. You sign in, and any of the resources the teacher used in that lesson are available to you. So is just a great resource for all subject areas, okay? So the lesson we're gonna watch is gonna stretch some of the intermediate a little bit, but in a theme type of way. And I'll actually ask you about that mathematics later, because we're gonna watch a 6th grade lesson, but it has to do with something that's relevant for all of you. Okay.
A calculator thing, directly into 3 sticks of 10 grid, and then 2 sticks of 10 group.
I set no limitations on their thinking. By knowing what students actually know, I can better dictate where the future lessons need to go.
So welcome you guys. You can see up front that we have our target for today. Today we're going to be working on creating a model that shows how two values compare to one another. Today we get the opportunity of trying to create the perfect color of purple paint. Okay? In fact, I'd like to paint our room. So purple is a better color, and look, just for the task, I wore purple today.
In the 6th grade lesson today, I introduced the idea of ratios and proportions. And we were trying to just help them understand the comparison of amounts and how they would scale that comparison.
Perfect purple paint is made by taking 2 cups of blue paint, okay, and putting it together, and taking 3 cups of red paint and putting it together. That makes 1 batch of perfect purple paint.
Our 6th grade class had never before been introduced to the concept of ratios, and surely not a part, and then whole concept. They might have looked at 2 different numbers and how they're connected. So their concept they were looking at was simply how are they scaling numbers. We were looking at the difference of additive versus multiplicative thinking.
For the first 5 minutes, you have some blocks on your table groups. I would like you, no paper yet, no writing. I would like you to take those blocks and think, how could you model 2 cups and 3 cups, but make it out of 20 cups?
This is about giving every student access at the initial stages. This way kids could visually see it, but they also could put their hands on something that made sense to them and really share their thinking with one another. So when we put them all on the same playing field by giving them blocks in their hands, they are more apt to start talking about their creativity in their diagram. We saw a lot of kids today that even though they kept the same ratio, were actually building pictures. And I'm okay with that. That's creative thinking. I encourage creative thinking. It's only going to deepen not only their engagement, but their level of knowledge of the task itself.
What I'd like you to do right now is to create as many models as you can as a group that show me your thinking for a model that represents how many red and how much blue out of 20 cups. To do that, though, we need to come to take consensus. When we come to take consensus, that means every single member of the group has to share their ideas. As a group, you're going to decide on some models that make sense to you. And only once you've decided will you start showing me those models that make sense to your group.
If we're really going to collaborate on a task together, we've got to really try to convince one another of our thinking. And really the only way to do that is to come to consensus. But students have to not only be good leaders in that they share their thinking, more importantly, students have to be really good listeners during that time and really see it as an opportunity to learn from their peers.
What if we doubled it? If we doubled everything like this one, but if I made it into different levels? Yeah. So should we color code it? So you're doing everybody's already doing the thing you're writing together. And well, here, that's the logic.
So our original one had 3 to 2. You have equal amounts. You have 11 and 9. What do you have?
Well, 12 and 8. So we have 3 different models right now. We have 11 and 9, 10 and 10, 12 and 8. But I'm going to be back in a few minutes to see which one makes the most sense to your guys' group. Okay.
I try to go back to the question and then restate the question for them, take them back to where we started and say, does that make sense for that? How can you tell me? When students don't have a response to my question, usually students start to think, perhaps if I can't explain it to her well, my logic might not be fully sufficient. So now you're back to this 11 and 9? Yeah. Okay, does that still show me my 3 to 2? So for every 3 red, do I have 2 blue? What do you think about yours? You originally had 12 and 8. Yeah. But now you changed to 10 and 10? Yeah. Where do I see the 3 to 2 in your model? Can I come back in a few minutes? I want you to show me in your final model, I want you to be able to point out to me, where do I see the 3 to 2? Okay, this is one, yes, one. Okay, so you have how many of those? Tell me again, each one represents the amount in one cup? Yeah, it's only 20. Okay, can you keep doing that? I'll even give you more blocks if you need them. These 2 are red, so I think they're red. That's 3. So 2 looks 30. Yeah. So originally you had 8 and 12, then you switched to 10 and 10. Now you're back to 8 and 12. Can you tell me why? Because red is 3, so the blue was originally 2. How many pairs of those do you have now? 4. And the red was originally 3. How many groups of that do you have now? 4. Which one makes more sense to you? The 10 and 10 or the 12 and 8? Why does that make more sense to you? Because there's an even amount. I don't have 4 groups. So at the end of the class, we have an opportunity where we come back together. During that time, students brought models with them so they can share that with the group. They've also.
And we're just gonna pause it for a second because we just watched her persevere and they're persevering. Well, only the one little boy really persevered and we didn't quite grab the other 2 yet, but hopefully some thoughts are beginning to take form. This was an introductory lesson to ratio and proportion, so this is their first time really kind of working with this idea of ratio. But what did you notice that she did at that moment? She came over to the table. They all had something different. What did you notice that she did? How did she handle it?
I like how she explained what each model was showing.
Oh.
And she didn't judge, you know, she was just like,
Yes.
there's 3 different. So when I come back, explain which one you think.
Excellent.
Which is hard as a teacher, because you wanna go, what do you think?
Right.
Or, you know, but.
She reminded them of that one fact, the 3 to 2.
Oh, that was
And
huge
said, "Go
for
back
me.
and look at yours with that."
And she laid out that 3 to 2, like, and she actually said, you must show me that 3 to 2 in your display. So it was like this visual prompt bringing them back to what the story really was saying. That part was huge to me. So, and you saw her doing a lot of question lines. To me, she really spoke to persevering. So, we're gonna watch them sort of summarize. Remember, I'm looking for you to just find some evidence of the math practices. I will give you a heads up though, there is sort of an error even on her part, in the summary. And I want you to kind of listen for it. There's a mathematical error that I'm sure once the lesson was done, she was like, oh my gosh, you know, one of these things. But listen carefully for it.
At that point, come to team consensus. Nothing can go onto their team document paper if they haven't all agreed to what's going on that paper.
All right, so when you share your model, I'd like you to tell us how you determined that model and how you used your model to determine the total amount of cups.
My model is each one of the blocks stands for 4.
Each one of the blocks is 3 by 20.
So in total we will have 20 and add it all up and it will be the 20 cups of purple paint.
Can I hold up? Tell me again, how did you know that each block stands for 4?
Because I did the math in my head until I added up to 20.
So you did
What
the
the
math?
blocks could be.
Okay, you did the math in your head until it's added up to 20?
Yeah, till the blocks could represent 20
Amy, can you share with us yours?
This is 1 cup, because there's 3 cups of red, 3 cups of red paint, and 2 cups of blue. So this is 1 brown.
Okay, so I asked Amy to bring hers because she took it down to 1 cup. And she said that in 1 cup, there was 3 red and 2 blue. I'm just wondering how you even knew that 1 cup would be 3 parts to 2 parts. How did you know that?
What's the ratio, so?
Where they currently are at the moment, I believe that they have an initial knowledge of multiplicative reasoning right now, and that they demonstrated that every group could scale the model up to 20 cups. So I believe that they're able to go perhaps into some numbers that don't look as friendly, sticking with whole numbers, and that they might even be ready to start to look at some decimal relationships as well.
Thank you guys so much for sharing your thinking with us today and letting all of us learn from you. Have a great day.
So before we talk about the math practices, did you catch the error? It was actually a language error.
I wasn't sure if I was right or wrong, because when you put the red and the blue together, you don't just have 1 cup.
You got
No,
it.
no,
Got
right.
it. It's really 1 batch. Yeah. And somebody said one of the students said 1 round.
Yes.
Kind of the idea of a batch, but it actually contains 5 cups.
Right.
Right. So you know,
That's for the 420.
You got it. You got it. And it was very interesting for me to watch the little boy kind of show his 3 to 2 and then explain that there's 4 in each cube. Middle school, just so you know, that to me speaks to the tape diagram approach. Because what you do is you set it up just like that, but you put a 4 in each of the boxes to show that multiplicative relationship. But I thought the use of the manipulatives really was applicable for all grade levels, and they really were working on this idea of both addition and multiplication within this problem. Tell me what evidence you saw or heard. Is there any math practice that you saw happening in this video?
Yeah, well, the whole idea of coming to table consensus is all about 3, being able to talk to each other, listen to each other, and explain.
Excellent, excellent. Yeah, even setting up that sort of format forces them to have to do that. Which was interesting to watch again with that little boy and the 2 girls, because they were like, yeah, we're doing that. You know, like, he kind of was doing his thing, they were kind of doing their thing. But still working on the whole like consensus together.
I think there was a lot of looking for patterns and seeing that they were coming up with different ways to get to that same 2 to 3 accent.
And I think the ones that made pictures that kept it 2 to 3 understood better than the ones that were trying to make.
Isn't that interesting?
Even though it was still 2 to 3, they couldn't explain it as well because they couldn't see it.
Well, that is a very interesting point that brings us to the group that really struggled, and then the boy did end up with the 8 and 12. If she had had him restructure those blocks, it's possible the other 2 would have made sense of it. Yeah, I agree with you. It's hard to see that structure when it's like a sort of a scattered display. Yeah. Anything else? Did you think there was any persevering going on?
Yeah.
What equipped the students to be able to persevere in this lesson?
Well, the teacher didn't say you're right or wrong. You know, just constantly saying, well, explain why, or go back to rethink the initial question of the 3 to 2. Instead of right off the bat saying, oh, you're right, oh, you're wrong.
Yes.
You know, I think that just that dialogue is really important.
Excellent. Excellent.
And trying to convince them to come to consensus because somebody had to give up their idea in order to do that. So they had to persevere to be able to say, okay, maybe I'm wrong and you're right. Somebody had to do that in order to come up with an answer.
I think too, personally, the fact that she gave them manipulatives was huge in this task. A lot of times we try to teach ratio and proportion problems just numerically. Or some programs will make them have to draw the model, but they're skipping that step of manipulating the blocks. And to me, that was huge, especially as she's starting in on this. One thing I would do differently though is use the colors of the paint. Anybody else get lost in what color was what?
The problem is, that's tough if we want to.
I know.
Blue and red.
I
If you're
know.
gonna do a classroom like that, it's.
I know, which is why she did the different colors, but I do think maybe with that one, maybe it would be cut out,
I was just gonna say, or
cardstock or paper or something.
Sometimes I gave the kids who needed that, like I knew there were some kids who needed those colors, so I would give them
Oh,
those.
that's a great idea.
I don't know, just once you got it more, 'cause I
And the
can't
ones
follow
that could abstract color to color, you could give them paper. Okay, excellent. So that video, what I did is, I did provide, I just want to kind of show you, on this slide, when you're in my slides, I did provide the link to the video, the look for document that I handed out to you, and then those questions that I had mentioned. That for each math practice, they've got a whole slew of questions that would be helpful, not only for the teacher to be asking, but eventually you can be pulling from them to equip your students to be asking. Okay. So now what I'd like to do is to kind of share with you two things. Some strategies that I think are like right on target with building the math practices, and then real quickly some resources to take with you. Okay. The three strategies that I want to briefly mention and give you some resources on. The first one is called a math talk. The second one is a 3-read strategy, and then the third one is my favorite. And to me, these are simple strategies that could be easily implemented that are like right on target with the math practices. The first one, a math talk. In the primary session, we actually watched a classroom video that was a math talk. So I gave that link to you. It turns out it was actually a 3rd grade video, but it was real relevant to our K2 group, okay? But in that video, he is actually running a carpet style math talk with a chart paper and recording information from students. So you get to see a really good example of that. And in that video, you see students using something called talk moves. And these talk moves are to encourage students in the language of the math practices. So how do I talk to my peers about math without teachers swooping in and saving the day all the time? But also, in a math talk, the teacher has an opportunity to do some symbols and some silent signals. So what you watch in that carpet style math talk is you watch students going, I agree with what I'm hearing, I disagree. Oh, that's what I thought too. They have a connection symbol, and the teacher has taught those students to kind of think, that's me, that's what I was doing. They also do symbols where they say, I've got 1 solution, I've got 2 solutions, I've got 3. So in that video, you watch these wonderful silent signals, which when I use them, give me a read on the class. So it's sort of a formative assessment, but it also provides a nice, safe environment for the learner to communicate with you without having to do it verbally. Okay, so it's really worth looking at. And then in the lesson, you hear them using this language. You hear things like, I would like to agree with what Heather said and add on. Or, I have revised my thinking now. These little 3rd graders are using that kind of language. So you can really tell in the video that they've been trained. I mean, this does not happen in a day. They have been trained over time to talk mathematics with each other. You also watch a nice turn and talk knee to knee with their partners. Okay, so really good resources on this tab if you're looking to get your students talking with each other more. Okay.
Branson, those are the posters that I shared with you. They have the verbiage on there, and then if you ever wanted to see Brittany Terramina use this, then answer those. So she, yeah. So if you ever wanted to talk to her about that, she knows all about it.
I was wondering if that had kind of gotten started, yeah.
So we started some math talks, but we didn't have the silent symbols, and that would have been so helpful because you had, if that would learn how constantly, it's like, let the other kids have a say, so that would have been really helpful.
You know, and this is just now making me think, there's another teaching channel video that is totally just about the silent signals that I'll add on to you. Okay, on the slides, where she just shows you different types of silent signals. Yeah. The next strategy, I have the steps here and I'm gonna explain it, but please understand, I've got a packet connected to it that you can see examples laid out. It's called the 3-read strategy. And it deals with this problem that you give a story problem to students and they just grab numbers and do anything to it. Well, here's how you solve it. Remove the question. They have no question to race off an answer. They only have a story stem. So if you think about your more complex type of word problems, those are the ones to do this with. Again, you just take that final question, how many peaches in all, or whatever it may be. Remove the question, you work from the story stem. And here's how you do it. The first time is typically the story is read out loud to the students, and all you want to know is what is the context. Before we race off and try to do math, can you even tell me what the story is about? Okay. The second read, you usually put the language in front of the students. And this time, you actually want to know about the math in the story. What are the numbers that you see? What are the implied numbers when they say dozen? What do they mean by that? And what do those numbers have to do with the story? The third read is a really fun challenge for all of you to think about and consider. You ask the students, what math question could they ask from the story? We're so used to giving them the question. Okay? And then just to kind of close up here, my favorite is a teaching channel video to watch where the teacher takes all the solutions, finds her favorite error, and then turns it into a lesson. So it sets a really nice premise that mistakes are valued. Okay? The last 2 tabs are just packed with great resources. Sorry, middle school. This one is just K-5, but then the illustrative is all right. Okay. I want to make sure that I'm closing out here so that on the last tab, those of you that have your computers open, you can click on this evaluation and it'll take you to the evaluation. You can skip the IEN number when you fill that out, but this is basically payment to the grant for the services. So that would be good. And nice contributions. I tried to jam everything into an hour, which was really hard for me. So if later you want to communicate with me about questions or more resources, let me know. Okay. Nice job. Thank you. For me, math practice is an hour is really hard. They're like so important.
How to get into what?
They only need one.
It's just the view only.
You just put your name on it, so then they
It was the last.
You gave her
There was
a
ticket card? Is that what? Okay.
I was looking at
I
website.
have 4. Yeah, so you just have the top ticket is what you're saying.
Yeah, either side she said.
Oh, yeah, just one.
On either side. Sorry, Hannah.
You got 3. Whoa. Yeah. It's fine. I shouldn't want people putting their name in the ticket and fine, but put their names on it, because they're not gonna need your phone number.
Now I understand. I broke the rules last time.
Sporty kids. Salad and stuff, it's all here.
And, this one was a little overlap with some of the things that are shared with you, but Wednesday will not be.
Okay.
Did it work? It's more personal.
Thank you.
Yeah, it's on the last slide. Click right on there. There you go.
Try to make it, we have to know what else.
No.
This one is each section.
The one at the end, perfect, yeah.
How they have it set up through this grant, but it's really nice that this grant, they're really flexible right now, they'll let me go out and do.
Sure.
You know, for stuff, so.
Thank you.
I'm not gonna take any of the raffle prizes again.
Yeah.
Oh, okay, well, this slide is a verification.
Yeah.
Yeah.
Guys want to say hi to Wendy?
Hi, Wendy.
Sorry.
Hi, Wendy.